Hello students, in this video we are going to discuss about another important property of solids, that is the magnetic property. Every substance has some magnetic properties associated with it, and the origin of these properties lies in the electrons. Due to the electron, the substances has some magnetic properties. Each electron in an atom behaves like a tiny magnet, and its magnetic moment originates from two types of motion. The motions are, that is the orbital motion and the spin motion. So the magnetic moment originates from two types of motions, that is the motion of electron, that is its orbital motion, that is around the nucleus, and it's a spin motion, that is around its own axis. Let us discuss the two types of motion of electron through this diagram. Now when you look at the diagram here, in this the nucleus is shown here, that is the atomic nucleus, and we know that electrons are revolving around the nucleus in a definite path, that is called as orbit. So here the electron is in motion, that is the motion of electron around the nucleus in a definite path. So that motion we can call it as a orbital motion. But the electron is itself undergoing a motion that is in its own axis. That is, the electron can spin around its own axis. That motion is called as a spin motion. So the electrons, we can say that they are in the motion, that is the motion of electron around the nucleus, that is called as orbital motion, and its spin, that is around its own axis, that is called as spin motion. So we can say that the magnetic moment originates from the two types of motion of electron, that is actually the orbital motion and spin motion. As we know that electrons is charged particle. So being a charged particle and undergoing these motions can be considered as a loop of current which possesses a magnetic moment. Thus each electron has a permanent spin and an orbital magnetic moment associated with it. The magnitude of this magnetic moment is very small and is measured in the unit called as Bohr magneton. The unit is called as Bohr magneton. Which gets represented by mu p. So what we can say that because electron being in a motion, it is associated with the magnetic moment, and the magnitude of this magnetic moment is very small, and it is measured in the unit which is called as Bohr magneton, and it is equal to 9.27 into 10 raised to power minus 24 a meter square. So this is on the basis of the motion, we can say that it is associated with a magnetic moment. So on the basis of the magnetic properties, the substances can be classified into 5 types. That is paramagnetic substance, diamagnetic substance, ferromagnetic, antiferromagnetic, and ferrimagnetic substance. So on the basis of the magnetic properties, we can divide the substance into following categories. So now we need to discuss about these types in detail. First one is the paramagnetism. The substance with one or more unpaired electrons are paramagnetic. When we take a case of an example, here one example is given. When we make the orbital diagram here, we can see that in this case, the total number of electrons are, here it is 2, 3, 4, 5, 6. Total 6 electrons are there. So when we make the orbital diagram here, we can say that the 2 electrons are unpaired here. these electrons are called as paired electron, and here two unpaired electrons are present. So the substances which having one or more unpaired electrons are called as paramagnetic. So how we can identify a substance be a paramagnetic? When we find its one or more electron being unpaired, we can call it as paramagnetic. Even these are weakly attracted by a magnetic field. When we apply a magnetic field, these are weakly attracted by the magnetic field. They lose the magnetism in the absence of magnetic field. That means when we remove the magnetic field, the substances lose the magnetic property. So such type of substances are called as paramagnetic substance, and this is called as paramagnetism. The examples for paramagnetic substance are oxygen, that is copper ion, ferric ion, and we have Cr3+. So these are the examples, and when you check, all these examples have unpaired electron. The next, when we take an example here, in this you can see that all the electrons are paired. So such type of substances in which all the electrons are paired, that is called as diamagnetic. So here one orbital diagram is given and the electrons are shown here in the form of arrows. So when you look at here, all the electrons are paired. So such type of substances in which all the electrons are paired, these are called as diamagnetic. These are weakly repelled by the magnetic field and they lose the magnetic character because the pairing of electron cancels their magnetic moment. Because here all the electrons are being paired, so the magnetic moment of one electron get cancelled by the magnetic moment of other because of being paired electron. The examples of diamagnetic substances are, that is water, NaCl, C6H6. So these are the examples of diamagnetic substances. The next one is ferromagnetism. The substances that are attracted very strongly by a magnetic field are called as ferromagnetic substances. In the solid state, the metal ions of ferromagnetic substances are grouped together into a small region which is called as a domain. So what is a domain? So the metal ions are grouped together into a small region which is called as domains. So each domain here acts as a tiny magnet. So when these substances are in the magnetic field, at the time all the domains get oriented in the one direction, that is in the direction of magnetic field. So that is actually shown here, the orientation of the domain, that is a magnetic moment, it is get oriented in one direction, and that is the direction in which the magnetic field is applied. So we can say that it get oriented in the direction of magnetic field and a strong magnetic effect is produced. So that is the special property of this type of substance, that is ferromagnetic substance. But in the unmagnetized piece of ferromagnetic substances, the domains are randomly oriented. That means the domains are randomly oriented in this way. But when the magnetic field is applied at the time, their magnetic moment get be oriented in the one direction, that is in the direction of the magnetic field. So in the unmagnetized piece of ferromagnetic substances, the domains are randomly oriented and their magnetic moment get cancelled. So these are the important points related to the ferromagnetic substances. And the example for the ferromagnetic substances are iron, cobalt, nickel, and we have CrO2. So these are the special properties of the substance which is called as ferromagnetic substance. And these substances are actually permanently, it can be permanently magnetized. The next is the anti-ferromagnetism. The substances have the domain which are oppositively oriented and cancel each other's magnetic moment, that is called as antiferromagnetic. Here also the magnetic moment, it is actually oriented, but how they are oriented? In the opposite direction. That means one is in this direction, the other one will be in this direction. One is in this direction, so we can say that the magnetic moments are oriented, but they are in the opposite direction. So the magnetic moment of one get cancelled by the other because it of being opposite in direction. So because of this reason only, we can say that the substances in which the domains are oppositely oriented and cancel each other the magnetic moment are called as antiferromagnetic substances. So here it is given the orientation where you can see that all are in the opposite direction. So here the spins are aligned in the anti-parallel in the, that is in the magnetic domains. Next, here the example is for this is M and O. The next type is ferrimagnetism. The substances have domains are oppositively oriented but in unequal numbers. So here also you can see that the magnetic moment, they are oriented in the opposite direction. That is, if one is in this direction, the other one is in this direction, next one will be in this direction, yeah, like this. So what is actually happening here? These are also in the opposite direction, but you can see that it is not in equal numbers. It is in the unequal numbers. That is actually the reason such type of substance is called as ferrimagnetism, because they have the domains which are oppositively oriented but in unequal numbers. So these are weakly attracted by the magnetic field and are called as ferrimagnetic substances. These substances lose the ferrimagnetism on heating and become paramagnetic. That is very important point here. It is also asked in the question that which substances is become paramagnetic on heating. That is actually ferrimagnetic substance. Example for ferrimagnetism is that is magnetite, ferrites. These are the examples of ferrimagnetic substances. So these are the important points related to the ferrimagnetism. So we can make the alignment here in this way. So you can see that in the ferromagnetic substances, the spins are aligned. These are aligned parallel in the magnetic domains. But here the spins are aligned in anti-parallel. Anti-parallel means one is in this direction, the other one is in the opposite direction. One in this direction, other is in the opposite direction. So these are aligned anti-parallel. But in ferrimagnetic, here also these are aligned anti-parallel, but they do not cancel each other here because these are in unequal numbers. You can see that both are in opposite direction, but these are in unequal numbers. So this reason these do not cancel each other. So these are the domains which is shown here, that is the systematic alignment of magnetic moment which is shown here. That is for the case of ferromagnetic substance, antiferromagnetic and ferrimagnetic substances. So these are the important points related to the magnetic properties of solid. So this is all about this video. Have a nice day.